Hello, my name is Gavin, and I'm one of the co-founders and the CEO of About Energy. About Energy is a business-to-business battery software and modeling company, and we make really advanced simulation models of lithium-ion batteries. So today I'm going to tell you a little bit about battery degradation. It's heavily simplified, but hopefully it gives you some idea about how you should use and optimize the lifetime of your batteries. So we're going to cover three topics. The first is to do with temperature and using the battery. The second will be to do with the charge rate that you should use your battery. And the third is to do with storage. So first, let's think about how a battery actually works. So a battery converts chemical energy into electrical energy whenever it's discharged. And these chemical reactions have to occur. Now, this chemical reaction rate is governed by what's called an Arrhenius relationship, which is an exponential with temperature. So for increasing temperature, the chemical reaction rate increases. And this is exactly why you keep your food in a fridge. Your food degrades through chemical reactions. And by lowering the temperature of your food, by putting it in the fridge, you reduce the rate of them chemical reactions. And even a small change, say from 25 degrees in your kitchen to 2 or 3 degrees in your fridge, is enough to preserve the lifetime of your food really significantly. And the same is true for batteries. When you're storing your battery, you don't want any chemical reactions happening. Them chemical reactions are side reactions degrading your battery. So you want to store it cold where it's really unfavorable for these reactions to occur. Now, the opposite is true when you want to use your battery. When you want to use your battery, you want the chemical reactions to occur. You want to convert that chemical energy into electrical energy and vice versa. And so you want to use it warm. The caveat being that if the battery gets too hot, you're going to have lots of them side reactions that are going to completely destroy your battery. And really above 45, 55 degrees, these are going to be very, very significant. So ideally, you kind of want to use your battery in around 25 degrees and store it as cold as you can if practically possible. So the second one is to do with charging. So the way batteries work is you have your cathode and your anode, and your lithium ions during charge, they move from the cathode to the anode. And this is a really simplified diagram, but hopefully it shows that these lithium ions, they move from the cathode through the electrolyte and the separator, and then they have to place themselves into the graphite. And people often describe this as a bookshelf, where the lithium ions have to kind of slot into the bookshelf. And this is a very rate limiting reaction on this surface. So if you try and move these lithium ions too quickly and slot them into these spaces, then they're going to start to build up on the surface. And when they build up, this is called lithium plating. And this is an irreversible reaction. So once the lithium ions have plated, they can't be used again. You've kind of destroyed them. And when you charge fast, this can occur. So the simple rule would be just charge your battery as slow as you can to prevent this from happening. Because when the lithium ions have enough time to move across, they can find the time to slot into their space on the bookshelf. And then the third topic I want to cover today is to do with storage. So we all think about batteries, and I'm as guilty as anybody when I started my PhD that they have a 0 and 100%. They're either charged or discharged or somewhere in between. But this notion is completely arbitrary and it's made up by us. In reality, you can discharge a battery below 0 because 0 is actually 2.5 volts. It's not actually 0 volts. And fully charged is typically around 4.2 volts. And you can go beyond these limits. But the problem with going beyond the limits is you cause a lot of damage to the battery. Some of it can be irreversible, and some of it, especially at high voltages, can be very dangerous. So manufacturers like Samsung, LG, Panasonic, they will just place voltage limits on where they've determined the kind of this damage becomes too much. And these are super round numbers, like 2.5 and 4.2 volts. And again, quite arbitrarily picked just based on damage. Now, the definition of SOC is even more kind of user defined. You could think of 0% as being 2.5 volts or 100% as being 4.2. But in many applications, like your mobile phone or your electric vehicle, often 0% in your car will actually be probably 2.8 or 3 volts, and 100% might be 4.1 volts. So they're basically narrow in this band of operation for your battery. And the reason for that is to prevent damage. The closer, as a very simple rule, the closer you stay to 50%, the less damage you'll do to your battery. And so whenever you're storing it, best to store it halfway if possible. Charging it to a high state of charge, especially beyond 85%, can do a lot of damage long term for storage. And likewise, the same is true for very low states of charge. So degradation, then, when you start to couple all these different factors, starts to get really complicated. You have this multi-dimensional space, and you can have lots of scenarios of, well, what if I'm at high temperature, high state of charge, and I fast charge? Or what if I slow charge at that? I mean, it creates this huge multi-dimensional space, and to actually do physical testing, like real experiments in this space, is really time-consuming and really expensive. So is what we do as a company is we make simulation models that allows you to probe this multidimensional space much, much quicker. And I wish that battery degradation was this simple, but in reality, it's a lot more complicated. So here's a great paper from the research group at Imperial College London, from Jacqueline Edge, called Lithium-ion Battery Degradation, What You Need to Know. And this paper is open source, so anybody can go and read it and access these diagrams. But this gives a little taste or flavor as to just how complicated battery degradation gets. And it's path dependent. Depending on what happened in the past, that will affect how it degrades in the future. But just to really simplify this into 3 key takeaways, the advice would be store your batteries cold and use them hot, around 25 degrees. Charge them as slow as you can. That's the safest way to protect your battery. And if you're storing it for a long amount of time, say many days or many weeks, you want to store it half full if practically possible. So thank you very much. And if you found this interesting, please let us know and we can follow up with more kind of informative videos. Thank you.